Okay, cool. Let's just get started with chapter 1 over here. Alright, so what happened with this chapter essentially, again, this is the first chapter of your Form 5 AddMath over here. Essentially, yes, it's supposed to be harder, but I would say this chapter is a blessing for you because the first chapter is really, really easy. Okay, in the sense that it is basically just a normal mathematics. Okay, it's basically as much as a normal mathematics, just with more cat element, maybe harder question, maybe a more complicated diagram. But essentially, as you know, the chapter is called circular measure. It's gonna just basically revolve around circle lah. Just a lot of circle, doesn't matter. Just a lot of circle, maybe a circle like that, circle like this, circle like this. Just a lot of different ways to draw circles, and then they ask you on different questions. That's the idea of this chapter. Okay, and in this chapter, essentially, why is it put under AddMath instead? Why not just put in the under mathematics? Because in this chapter, we are not gonna do circle in the normal way. What do I mean by normal way? The normal way, we will have angle 0 degree to 360 degree. We will have circumference as 2 pi r, right? I think this is something people, I hope you will know, this, okay? You should do in your mathematics as well, 2 pi r. Then we have area equal to pi r squared, right? And if you have angle, what happens? If you have angle, you just have to basically multiply it with the angle over the total. The total is shown over here. The total is basically 360. So that's what you do when you have angle. And this is what you have been learning so far, I think ever since you are from 1 until now. This is a formula you use for circle. Now, what does AddMath do over here? They basically just try to, revolutionize a bit over here. Try to reinvent the wheel, and then try to basically introduce a new way for us to see, or to say, for us to view angle, okay, from a different perspective. So what is this new perspective? Let's see. So essentially, they are trying to, they feel like basically, look at this, 2 pi, you see, you have a lot of process over here. It seems to be a little bit too complicated. They want to simplify the process, and they want to standardize the entire, measurement of angle, essentially. Okay, so what they do over here, you see, they realize that by a simple theory, if you look into just, let's say, a specific angle, let's just say a circle, right? Okay, of course, I think by the logic of it, the larger the radius, right? The larger the radius, the larger the circumference. There must be a ratio between radius and circumference, which I think you should be able to see. Circumference, let's just put S, I call it S over here. S equal to 2 pi radius, 2 pi r. Circumference basically is 2 pi of r. That is the radius, that is the ratio lah. S over r equal to 2 pi. Do you get me? Yeah, that's the idea over here. Moving on, if you see, even if I have a pi, I have a certain angle over here. Doesn't matter, the rule still apply. Of course, the larger the radius, the larger the circumference. Again, I hope it makes sense, because if you extend this radius to be bigger, then yes, the circumference also become bigger. So again, we can still see that there will definitely be a ratio between S and R. That's a brief idea over here. Again, in this case, S and R, it will be, again, remember the normal formula, 2 pi r multiplied by angle over 360. So now in this case, still we can see that S over R is basically 2 pi times 2 pi times 你的这个 angle, your angle over here, over 360 degree. That is how you can find. So what do we see here? We see that S and R, remember what is S? Again, this word you're gonna use it a lot. So what is S? Circumference. S and R, circumference and radius, actually do have a specific ratio over here. As shown over here, 2 pi times the angle over 360. And this is when people feels, since you can have a specific ratio, why not we just use this, Why not we use this as our new angle measure protocol, new angle measure standard? Okay, so what I mean over here, essentially, let's not talk about the degree anymore. Let's not talk about 0 to 160, whatever. Let's try to use 2 pi and whatever over here to represent angle. Okay, so essentially, if you go back to here, instead of saying 0 to 360, we can see that what is 360? It is basically a whole circle, which you can actually say 2 pi. Let's just say 2 pi. Right? Let's just say 2 pi. Instead of saying 300, like I said, instead of saying 360, let's just say 2 pi. Okay? Instead of saying 360, let's just say 2 pi. And you see now, how can this benefit? because let's just look at these two equations. How can this be better? How can this benefit you? Because you see 2 pi r multiply with theta over 2 pi. What happened here? Simple math, cancellation. What is my final answer? Simply r theta. That's it. As simple as that. Then you get a new formula over here. This is your new formula, and you cannot operate it in terms of, you know, a new so-called domain, a new language over here, a new language. Yeah, I call it a new language of angle over here. Similarly, you can see your formula for area. Pi r squared multiplied by pi theta over 2 pi. What happened? What is the new formula? Yes, you cancel things out. You will get 1 over 2 r squared theta. Yep. So with that, you then be able to get this is the two new formula over here, r theta as well as half r squared theta. That's how you arrive at the new formula over here. Okay, yeah. So again, this is just a basic over here. We are not gonna go so far into the area and the circumference or whatever, but essentially this is the essence. The essence is that you want to simplify the whole process over here by simply converting your angle from 360. We convert to something called 2 pi. So basically, we try to express your angle not in terms of degree anymore. We express in terms of pi. Again, we express in terms of pi. And again, why do we do that? Because we want to make it simple. Okay, cool. So this is what Santi has found so far. And again, indeed, if you go further into, you know, let's say you go to engineering, you go to a lot of further calculus or mathematical studies, okay, in university, you indeed will see that whenever people talk about angle, they will not use degree anymore. Usually they won't do that. They will just tell you, oh, I want pi, I want 2 pi, you know. You need to be very clear. Oh, 2 pi is this angle or whatever. So this is basically like another language over here for you. The language to communicate between basically the language between angle in degrees and angle in radians. Okay, just to give you an analogy over here, you can just imagine it is two different forms. It is two different forms of angle. One is about degree, so we have 0 to 360 degree. One is about radian. Yeah, this is a name over here. We call it a radian. Radian would be ranging from 0 to 2 pi. Okay, this is the idea over here. Again, you can just, let's say number. If you also learn about number in mathematics, did you? I think you will learn it from 5. Yes, anyway, so you see number, we also have multiple different format. To represent it, you can represent in decimal. That will be 1 to 10. You can represent it, 0 to 9. You can represent in binary. That will be 0 and 1. 0, 1, 0, 2, 0, 1, 1, 0, 1, 1, 0, you know, those kind of stuff. That's binary. You also have a lot of different ways to represent your number. In this case, binary. So you see, this is the key over here. It's just another way for you to represent stuff. It's the same thing. It's the same thing, just in another language. Okay, so I think you can see what happened over here. Basically, we're just gonna do all the typical question. I give you a circle, you give me the circumference, whatever. Typical question, maybe a bit harder, but typical question. But we're gonna do it in what? We're gonna do it in radian, which is 2 pi. Okay, which is in terms of pi. Yeah, that's the idea over here. Common unit, we're gonna say something pi radian. Okay, when you see radian, this essentially means this entire thing operates in radian. If you don't see radian, but you see something pi, this usually also hints you that, okay, it's a hint to you that it indeed is a radian. Okay, yeah, again, because sometimes people just do not, they assume you will know it's a radian, they will just use, you know, radian. Okay, yeah, but of course I will encourage you to put the word radian just to make it clear, because still, I think, do you still deal with? Yeah, there might be chances you still deal with, you know, degrees. So if you want to be clearer, just to put the radian over there. Yep. And then I think yes, if you talk about, if you just see like a number let's say just a number, let's say like this, tangent this. Okay, again, this is hard to tell whether or not it is supposed to be a radian or it is supposed to be a degree. Okay, but I would usually say, okay, again, I think not really applicable in SPM because the question should be quite specific, okay, clearly stated to you. But in the general life cases, right, in the general application, when you see this, people usually assume this is radian. Okay, like I said, because radian is the more preferred version of angle, a more preferred language to communicate angle, and also that this number is so small. Who will measure 2.713? Like, that's really too small to be in a range of, you know, in a range of 360 degrees. That seems a bit odd. Okay, this doesn't really make sense. Yeah, but if you tell me this is under 2 pi, it actually makes sense because 2 pi is just what? maybe 6 something, 6 point something, which is okay to have 2.7. Okay, yeah, so I think in that case you can also imagine this probably would be a radian. If you see tangent 50, this one I think quite straightforward. There's no any doubt. I don't think this would be radian because this is gonna be what, 50 over 2 pi. That's really huge. Okay, but if it is angle, this is in degree, it's just 50 over 360, which makes sense for you to have an angle of 50. So again, this is just a bit of idea between these two representation, and usually we still stick with, again, we stick with the pi form over here. We call it radian. Okay, that's the main thing over here. Cool. Right, so if all good, we'll now move into the first thing we learned today. How do we convert between that to angle? Okay, yes.